Good afternoon, everyone. I hope you can hear me well. Perfect. My name is Tunca Sekban. I am the Senior Offering Manager for Honeywell. As you all know, we provide refrigerants to different applications, and today I will be explaining a little bit about the heat pumps that will be running on HFO systems, and then the benefits against gas boiler replacement. Approximately 40% of the buildings represent approximately 40% of the energy consumption, and 80% of this comes from heating, cooling, and hot water, as well as the efficiency, or let's say the energy consumption. There's about 36% of buildings also is the reason of green gas emissions. So when we talk about the heating demand in buildings, we talk about mainly the space heating and hot water generation. And the ratio between those two depends on the type of building, so the purpose of the heating in these different buildings, as well as the building envelope, which means how well the building is insulated and what's the target of that building in terms of energy efficiency and consumption. So it's important to understand that needs are different. So the space heating is seasonal, but hot water generation is throughout the whole year. So it's important that we understand what is the need for each type of buildings. Looking at the possible use of heating, you can see on the right-hand side different uses in different type of buildings. So looking at the low temperature demands, we see the tendency in the market to be used air source heat pumps providing these type of temperature outputs. Whereas if we go into higher temperature outputs, we see the use of water source heat pumps or a cascade system, which is a combination of air source heat pump together with a booster heat pump, providing these high temperature needs of the heating system. So looking at different type of commercial buildings, I think each type of buildings requires different heating demand, but looking at, for example, office buildings, you see zonal heating and cooling required in different meeting rooms. Looking at the hotels, you see again different heating demands in different rooms where someone may want to heat the room, whereas someone may need cooling. But again, on the healthcare, on the other side, in hospitals, you need almost 24 hours hot water generation, which is important to be considered when it comes to deciding in technology on heat pumps. So, long story short, the simultaneous heating and cooling is needed when it comes to different type of commercial buildings, but it's important to identify what is used and what is the need of each building type. So the path to decarbonization in buildings, we usually consider, and if you come from equipment manufacturer background, then you will probably appreciate that making the decision on the right equipment and refrigerant use in that equipment actually consists on 4 different pillars. Main one is energy efficiency. We all talk about energy efficiency. But as well as efficiency requirement, we also need to consider the safety element, the total cost of ownership, as well as the carbon footprint. And we believe that HFOs provide an optimum solution that actually touch on all these pillars, providing the safety elements as well as carbon intensity, total cost of ownership, and energy efficiency in different type of equipment that are used today in heat pump technology. Very quick overview on the regulatory side. We are aware of the F-gas regulation and its its impact on the choice of refrigerants. We see that on the legacy refrigerant prices that are increasing almost every year. And also, we also see different local regulations that basically touches on the, basically puts some taxes on higher GWP refrigerants. There are examples like Denmark, Spain, Norway, where we see higher prices of refrigerants, not only because of the F-gas pressure, but also the local regulations that put additional tax on high GWP products. And apart from that, we also have countries like Belgium, Netherlands, France, Germany, which basically put bans on fossil fuel gas boilers, mainly in new buildings, which will also spread out to existing buildings. So it's important to understand what will be used and what can be used as a heat pump technology replacing those boilers that provides the right heating temperature with the right refrigerant. So that can be provided with the right refrigerant. So what we see actually on the market is, compared to the legacy systems, heating and cooling systems, which are where the cooling is provided at a separate chiller and the heating is provided by a separate gas boiler, we see the tendency of multi-purpose heat pumps, which basically provide both heating and cooling, both on the hot water generation and space heating side. And this way, building owners can save on the capex, because instead of two different systems, they only need to take care of one system. This also has some implications on the maintenance side, so they only take care of one system in terms of maintenance. And also, thanks to the new HFO technology providing high temperature, you can also see some significant savings on the efficiency, energy efficiency, and operating costs. And the last but not least, because HFOs provide low global warming potential, building owners see the benefits of lower carbon emissions, which obviously help their building value going higher compared to old systems. This is the Solstice Refrigerant Outlook that basically summarizes the use of HFO refrigerants for different equipment types that provide heating and cooling in buildings. On the left-hand side, you can see the equipment type. So the first one is chillers and heat pumps. And you see also the market solution, the HFC solution, and then the capacities, which have been also laid out in the latest F-gas revision. There are some proposed bans that's been laid out in the latest F-gas revision. So some equipment type will not be able to use refrigerants above 750 GWP. From 2027, for example, above 12 kilowatts in chillers and heat pumps, whereas below 12 kilowatts will not be able to use any refrigerants above 150 starting from 2027 for below 12 kilowatt equipment. Coming to rooftops and VRFs, we see a similar tendency where 410A refrigerants will be replaced with different refrigerants, lower global warming potential refrigerants, starting from 2027 up to 50 kilowatts, and above 50 kilowatt, there will be a change again below 150 starting from 2030. As Honeywell, we would like to offer to our customers both an interim solution, which usually doesn't require significant design changes, and help our customers reduce the global warming potential by providing highest efficiency, whereas our long-term solutions usually go very low GWPs, usually below 10, like you can see in ZE1234ZE, replacing providing the long-term solution in oil-free and screw chillers and heat pumps, together with 515B refrigerant that also provides a non-flammable option, which is actually a good flexibility for the building owners, especially for maintenance as well as ease of installation purposes. For the high pressure equipment type, the rooftop and VRFs, we see more and more OEMs use 454B as well as R32 and VRF systems. And 454C, we believe 454C provides the right solution below 150 as a long-term solution that provides the right temperature levels, as well as providing the right GWP, which will provide the compliance and the right temperature output for these product types. So overall, when it comes to heating and cooling demand, we see significant savings of use of HFO systems and heat pumps, with more than 90% at total cost of ownership, and that will be 50% lower than fossil fuel alternatives. And I will touch on this in a couple of slides with real case scenarios. And apart from the refrigerant end, we shouldn't forget about lowering the heat demand for each building, which can be provided with additional insulation. And that can be provided with our XPS board Solstice GBA on the roof insulation, and our Solstice A LBA that provides wall insulation, increasing actually reducing the heating demand and increasing the insulation of your building envelope. So this is one of the projects that we work with company Train. This is a hospital project in Malta. The original the opening of the hospital was in 2007, and the customer, the Mater Dei Hospital, decided to replace their boilers with heat pump technology. And the good thing about this project, and the reason why I wanted to take this, is this gives us a clear comparison between the old systems, which was based on cooling chillers, as well as boilers for heating and hot water generation. So at the end of the replacement work, our customers have seen 1 million liters of annual reduction of diesel fuel consumption, preventing 2,700 metric tons of CO2 equivalent reduction, as well as over 58% savings in fossil fuel-related energy use. So compared to the boilers that will be consuming significant energy for hot water generation and space heating, with the HFO heat pumps that they have used in the renovation project, they have witnessed 58% savings in overall throughout the year. And this is not an estimation. They have, this is a Train, our partner OEM, partner OEM who provided the replacement units, replacement heat pumps, using 454B and 1234ZE refrigerants. What they have done is, after replacing the boilers and chillers, they have measured the savings, both in domestic hot water and central heating throughout the year. And that's the way how they come up with the savings of 9,159 megawatt hours, and with the savings of 2,722 tons of CO2 equivalent. So this is significant saving, especially looking at the commercial buildings. So you can save on the operation costs, you can save on carbon emissions, you can actually convert your building to a more environmental friendly building, and that way you can provide the right temperature level output, both on heating and cooling side. This is another project that we undertaken in London with Southwark Council. So Southwark Council own a lot of building blocks and they wanted to benefit from the funding that they would receive from UK government. And they simply, using this funding, they simply converted their the boilers on their building stock to heat pump technology. And since the heat pumps were based in indoors, they chose Solstice N15, which is the non-flammable option to 1234ZE. That provides a temperature output up to 100 degrees, whereas the council's network usually operates around 75, 80 degrees Celsius. So this way, they not only reduce the carbon emissions caused by all these boiler stock, they also save significant costs on operation with the higher temperature output they needed for heating these buildings. This example, I've taken this because this is a good example of increasing the value of a building by replacing the existing systems with the HFO system. So our partner Geoclima with the University of Nottingham project, after replacing the old chillers, they have managed to obtain the BREEAM and LEED credits, which obviously was an example for that type of system or that type of building system, as well as taking it for different commercial buildings that can potentially increase the value of the commercial building by obtaining these licenses and these environmental accreditation. And the last example that I would like to put here is, again, something that we could quantify in terms of value and savings. This was a project, again, in Derby College, where we managed to replace existing boilers with a combination of air source heat pump with 454B with a booster heat pump with 1234ZE. And this way, the customer Derby College managed to save 790 90,000 kilowatt hour energy, which translates into approximately 70,000 pounds per year in energy costs. And this is basically replacing the boilers that basically with air source and water source heat pumps that provide both heating and cooling to this college. And not only that, obviously, the emission reduction in this building helped them to grab the award. The project won a heat pump award in 2022 by replacing boilers. So these were the examples that I picked up, but there are many of them using different heat pump technologies. So if you're interested in refrigerant solutions that can be used in heat pumps, reversible, as well as cooling only chillers and different equipment types like rooftops and air source and water source heat pump systems, please come along. We are in Hall 6, it's Honeywell, and thank you very much for your stay.